believe. So we're not interested in any Bayesian personal probabilities, but instead we look at objective or logical probabilities conditional on some evidence. And these probabilities are accessible by reason alone. They don't depend on our heart, our will, or our affections. And I'll call that the probabilistic assumption. Now, it's generally held that the rationality of holding a belief is dependent on these two assumptions, and I'll call that the standard view. But what I'm going to argue is that holding this standard view leads to very unintuitive consequences. So I'm going to look, in this paper today, what I'm going to do is I'm going to start by looking at the core assumption. I'll grant the probabilistic assumption. And what I'm going to show is that we would never use the core assumption in science or in ordinary belief. In philosophy of religion, most of our arguments focus on austere theism instead of the rationality of beliefs that people normally hold, such as Islam or Christianity or Judaism. And interestingly, Plantinga's early work tended to focus more on austere theism, but over the course of time, his work deals with the rationality of Christian belief. And so in today's talk, one way of viewing it is in support of that. I'm arguing in support of the shift in his thinking. And then after doing this, what I'm going to do is very briefly, just look at the evidential argument from evil. And the reason I want to do that is I want to show how different it looks if we reject the standard view, if we reject the core assumption and the probabilistic assumption. Okay, well, let's look at the core assumption. According to the core assumption, if I have some evidence and a hypothesis, I'm not interested in probabilities such as how likely the evidence is on the hypothesis or how likely the hypothesis is on the evidence. Instead, I look at the core of the hypothesis. And instead, I want to look at how likely is that core given the evidence, or how likely is that evidence given the core. Now, one reason the core assumption is so appealing is that if it were successful, if it were legitimate, it would provide a way to reject all variants of a theory. Philosophers such as Kuhn, Duhem, Lakatos, and others have noticed that if you have problems with a specific version of a theory, that you might reject a theory. It may have empirical problems, but the core ideas survive, and new variants, new versions of the theory are generated. So if you want to argue against a whole theory or a whole research program, it doesn't do any good to just argue against one version because they'll develop a new version of the theory. So it would be really nice if you could have an argument against the very core of a theory that would prevent all other versions of the theory from being developed. So for example, if you could show the core of a theory was logically inconsistent, as we all learned in intro logic class, that inconsistency transfers to any theory that contains it. And so then you would have an argument against all versions of the theory. So the potential for an argument against all versions of a theory is one reason the core assumption holds appeal. Well, how might you support this? Well, one way you might try to support the core assumption is by what I call, or I've decided to call, the converse consequence disconfirmation principle, and it's written on your handout. And I sort of named this after Hempel had a converse, a similar principle. It basically goes like this. If you have a hypothesis H, and it logically implies H star, if you have some evidence that disconfirms H star, that evidence disconfirms the hypothesis H. Basically, if you disconfirm the consequences of a theory, you disconfirm the theory. That's what this says. Now, if this principle were right, we would have a justification for the core assumption. The core assumption, what it does, it looks at how some evidence bears on the core of a theory. And so if you disconfirm the core of a theory, the problem you then have is how to transfer that disconfirmation of the core back to the theory itself. The converse consequence disconfirmation principle does that. It says that disconfirming the core of a theory will transfer back to disconfirmation of the whole theory itself. So applied to philosophy of religion, if you had some evidence against or something that would disconfirm austere theism, the converse consequence principle would allow you to transfer that disconfirmation back to Christianity itself, and you would therefore disconfirm Christianity. So that's one way you might try and support the core assumption. But there's one big problem with the core assumption, and it has a very unintuitive result. Namely, any hypothesis is disconfirmed by any contingent fact that's independent of it. So for example, the hypothesis or belief that Plantinga has climbed several 5'10" rock climbs is disconfirmed by his having Frisian ancestors. Okay, but that's crazy. Certainly his having Frisian ancestors, shouldn't lower the probability of him being able to climb 5'10". So we're going to have to reject the core principle. So you cannot use the converse consequence disconfirmation principle to justify the core assumption. And there's lots of other problems. For example, it's really easy to give examples of hypotheses or evidence where some evidence will, if you have two theories, will disconfirm one theory, disconfirms the other theory, yet it confirms the conjunction of the theories. So applied to Christianity, it's possible you could have evidence that disconfirms or lowers the probability of austere theism, lowers the probability of God existing. Maybe it lowers the probability of the various Christian doctrines, and yet raises the probability of Christianity. No implications for the effect of some evidence on something like Christianity can be deduced from its effect on the core. So even if some argument could successfully show that evidence disconfirms austere theism, that tells us nothing about how the evidence affects Christianity. Okay, now I want to talk about another argument against the core assumption, and that is that it would give us very unintuitive results if we were to use this in science. Since at least Duhem, we've known that when we generate predictions from a theory in science, we don't use just the core of a theory, we use the theory plus various assumptions. To generate empirical predictions, the theory needs assumptions and other things to get the predictions. And you put the theory plus the assumptions to the empirical test. If it fails the test does not cast doubt on the theory, but on the conjunction, the theory plus the empirical assumptions. Putnam even goes so far to say that if the theory and assumptions fail the test, it's very likely it's not the theory that's at fault. It's likely that it's the assumptions, but we don't need that claim. So suppose we adopt the core assumption and we were to use it in comparing scientific theories. What I want to argue is that we're going to end up rejecting many of the theories we currently hold. So let's just take an example. Let's look at quantum mechanics, which is, I will take to be our modern version of atomism, which says there's small particles. Well, let's compare that with a couple other theories. One is that there's no unobservable particles down there. And let's say a theory that there's nothing at all, just a plenum. And let's let our evidence be some of the strange empirical phenomena of quantum mechanics. Let's say that if there's particles, they sometimes behave as particles, but sometimes they behave as waves. Or you could take other evidence, like they don't have a specific location in space-time, or there's no precise number of them. Whatever, take your favorite strange empirical phenomena. Now, this evidence is all handled very well by our modern scientific theory. The theory was designed to deal with this evidence and to account for them. But that's irrelevant, according to the core assumption. According to the core assumption, we look at the core of quantum mechanics, which let's say is simple atomism, and see how likely the evidence is on that. So, how likely would it be that if there's particles, they behave as waves sometimes as particles, on the assumption of simple atomism, and on the assumption that there's no subatomic particles, and on the assumption that there's nothing at all, just a plenum? Well, I mean, these probabilities are really hard to assess. I don't really know any precise values. but I think it's very plausible